This video is going to walk you through what you missed today in today's meeting. First of all, if you want to do a Chapter 9 retake, you'll need to go to the Modules section, scroll down to the very bottom, and you'll see that there's a Chapter 9 test remediation. Finish that first, and then you can email me when you're ready. And when you take the retake, you'll be getting one attempt this time as opposed to two, and we'll replace the score with that new score. Hopefully that's enough. Next, we'll introduce real quick the Chapter 10 and 11 notes and ideas. It's mainly just formulas. We're going to be covering pyramids, cones, spheres, and then some concepts that are around circles. So let's begin with pyramids first. The first thing you need to know about pyramids is that we have to find the surface area and the volume. All you're going to have to do is find the area of the base, or we'll be working with regular base pyramids. So when they're regular based, it's like Chapter 8 where you dealt with regular polygons, like in this case a pentagon, or an octagon, or a hexagon, or in this case a square. Now once you find the area of the base, you're going to have to take 1/2 times the perimeter of your base, that's the distance around the edge of the base, and then times the slant height. Now that word slant height might be kind of new to you. That's the distance from the edge of the base up to the tip of the triangle or the pyramid, and that's called the vertex or the apex. That distance is the slant height, and that's important in trying to find the surface area of all four lateral sides. Then, as we move on to finding the volume of pyramids, you're going to be taking 1/3 times the area of the base that you're already familiar with being able to do, no matter what shape it is as the base, and then times the height. Remembering that the height is always the vertical distance from the apex or the vertex to the middle of your base. That's perpendicular, not this one. Also note that some homework questions will have this distance given to you and this distance given to you, and you may have to use the Pythagorean theorem to find the missing side. When you have a regular shape, also we'll assume that it's going to the middle, so that if you get this side length right here, if you chop it in half, that would also give you this length that's across here as well. All right, let's move on to rectangular-based pyramids. Rectangular-based pyramids are not going to be in our assessments, but it is good to be aware of them. What makes them different is their dimensions of the base are different, which then creates different sized triangles. So it's found the exact same way. You find the area of the base, that would be A times B. But when you're finding your lateral triangles, you have two of these and you have two of these. Now if I do 1/2 base times the height and then multiply by 2, the 1/2 will cancel. So if I just simply take A times the slant height of the front plus B times the slant height of the right side, then I'll have my total lateral surface area for the pyramid. Again, volume works the exact same way as the regular ones. It's 1/3 area of your base times the vertical height that you see in the shape. Let's move on to cones. Cones are just like pyramids. They have a base and they have a height and they have a slant height. So we just use the formula for surface area. You just take pi r squared, the radius that you're given, plus pi r slant height, where you're given the same radius again times the slant height that you see here. Now sometimes you'll have to be using the Pythagorean theorem, like I said earlier, to find the missing pieces. You might be given the height and the radius, and you might have to find the slant height with a squared plus b squared equals c squared, and some piece will probably be likely missing when trying to solve these problems. Volume works the exact same as the pyramids. It's 1/3 the area of your base, pi r squared for the circle, and then times the height. Let's move on to spheres. Spheres work the exact same way. Spheres are just 4 pi r squared, where r is your radius. Just plug that information into the formula and you'll have your surface area of the sphere. Volume, if you want to find that one, you just take the radius again and cube it. It's 4/3 pi r cubed, and you'll have your volume of the ball. If you want to know where these formulas come from, we have some videos built into our assignments that help explain them. Now let's talk about circle vocabulary that you need to be aware of to be successful with this part of the chapter. When you see a little circle with a P here, that just means that P is the center of the circle. And if any line segment goes up to it or through it, it's going to either be a radius or all the way through it, a diameter, as mentioned as you see right here. Next, the word chord. Chord means it has a line segment with endpoints on the circle. That'll come into play where we ask you to find the length of this chord sometimes, based on the angle that's formed up here at point P. Now, if you understand anything about polygons like you did earlier, you can take this shape, which is going to be an isosceles triangle because the radius is the same length on both sides, and that angle then gets cut in half and you can make right triangles. Right triangles can then be used along with that angle then to help you figure out the length of the chord. And other things you might be able to use to find that length of that chord also are the law of cosines, where you might know the radius, this distance, the angle in the middle, and this distance, which is side angle side, and with the law of cosines you can find this missing chord length also. Moving on, if we talk about secants are lines that shoot through a circle and intersect the circle in two places. Tangents are special because they're a line segment or a line that would go through a circle and just skim the edge and only touch the circle in one point. As for our last piece of information, you need to know something about arc length. Arc length is the amount of circumference traveled from a point to another. If I say what's the arc length of DE, You did this earlier in the previous chapter where we asked you to find this distance, and that distance is measured by the angle over 360 times pi times diameter. That distance is a unit of measurement, typically like inches or feet or whatever it might be, but it's a distance. If we say arc measure is the amount of degrees between those 2 points in the entire circle. So if I have a central angle of 50 degrees, I'll have an arc measure of 50 degrees also. Central angles always have an angle at the center, where the vertex is at the center of the circle, and we also have what are called inscribed angles, where the vertex is at the edge of the circle. What's special about these is that they're always going to be half of the arc measure that they go out to. So if I have an arc measure of 64, then I will have an inscribed angle on the inside here at 32 degrees. Some other things to notice is that you'll notice that angle B, this angle B right here, is also an inscribed angle, where its angle is on the edge of the circle as well. However, it opens up to a diameter. When a diameter cuts a circle in half, which is normally 360 degrees, and we cut it in half, that means this arc measure is 180 degrees. And it basically means that anytime you have an inscribed angle that opens up to a diameter, it's always going to be 90 degrees. That'll be important because when you have triangles that have 90 degrees in them, I can use the Pythagorean theorem to find distances, and I can also use 180 degrees in a triangle then to find the missing angles. Also, if I know that that's 32 degrees, to get to 90, this has to be 58 degrees, which then means if that's 58 degrees right here as an inscribed angle where the vertex is on the edge, then I should know what this measure is right here by doubling 58 degrees. 58 degrees doubled is going to be 116. Or I can also know that the circle itself is going to have 180 degrees right here. If I take 180 degrees minus 64, I'll also have 116 degrees. So there's several ways you'll like solving these puzzles of missing angles and arc lengths and arc measures, just knowing some special things about circles. The last thing I want you to know is that all the information I've just given you here today is available to you on our calendar as a slideshow, or downloading our formula sheet that I've also made for you. That is right here, that has all of our formulas that I've just talked about. Hopefully this information helps, and good luck this week in getting into pyramids, spheres, and circle information. Good luck.